prove that f of x is an increasing function. So when the question states that, we've got to show that this is increasing function for all values of x. Okay, so we need to prove somehow that the gradient, okay, is positive always. All right, so let's work out what the gradient function is. So remember, gradient dy by dx, of course, f dash of x is the other way of writing it. So if we differentiate this, bring that 3 down, so 3 times 4 is 12, reduce the power by 1, bring that 2 down, 2 times 12 is 24, reduce that power by 1, and then 17x becomes 17, the minus 3 disappears. So we've got to show that this is always positive. Now it's not as simple as the last question, okay, because we've got like an x term here, all right. You know, I can always show that this is positive here because x squared makes things positive, but this here won't always be positive, okay. This instances when it will be negative, and it might take the overall sum to be less than 0, okay, if this is super big, for instance. Okay, we don't know that, right? So we've got to prove that this is always positive. So how are we going to go about it? Well, one way is to complete the square. Okay, so if you remember you're completing the square, okay, then we can show that actually it's always positive. So completing the square method, if you recall, well, I'll take that function there. And of course, when you complete the square, I can't have like any digit here greater than 1 outside the x squared. So what I'm going to do, I'm going to factorize out 12. Okay, whatever number's in front of the x squared, factorize it out, square bracket, and then what do I times by 12 to get 12x squared? Well, that's x squared. And then what do I times by 12 to get minus 24x? Well, that'll be minus 2x. Close the square bracket. I'm only going to factorize the first two terms and then add on the 17 at the end. What I can do then is I'll zoom in, and I will complete the square inside that square bracket, because of course now I've got an x squared there, which is what I need for completing the square. So when I complete the square, remember you've got this, so what I do is I do a bracket, x in the bracket squared, and I halve that, if you remember. So half of minus 2 is minus 1, that's what's going to go there. And then I always take away the square of that. So if I square 1, well, that's just going to be 1, isn't it? Okay, close square bracket, and then we're going to add, then don't forget, then add the 17 on. Next step then, okay, let's tidy this up, let's simplify this process here. Okay, so I'm going to multiply through that square bracket by 12. Okay, so I get 12 bracket x minus 1 all squared, and then times the 1 by the minus 1 by the 12 as well, so minus 12 plus 17. So I get 12 x minus 1 all squared, and then minus 12 plus 17 is plus 5. Okay, now I've completed the square and I've got my f of x to equal this, and this bit now is revealing to us, because if you think about it, okay, this bit here is always got to be positive, isn't it? Because there's a square there, yeah, you're squaring that bracket, so it's positive, all right. And of course then we're adding on 5, which sort of makes it even more positive. So we'll just say, look, since x minus 1 all squared is greater than or equal to 0, okay, can equal to 0 of course when you square something, because when you square 0 you get 0. Any other value when you square it is positive, and then 12 times it, but plus 5 has got to be greater than 0, isn't it? So therefore f of x, okay, I should say f dash of x there, isn't it? So because f dash of x is positive, the gradient is always positive, therefore f of x is always an increasing function for all x. Okay, now there is another way you could have done this, right? Rather than completing the square, you could have, right, the alternative method was to take f dash of x, look at that there, okay, and appreciate, okay, that we want this to be positive always. So in other words, it can't equal to 0, yeah? So if we want this to be greater than 0 always, it can't equal to 0. Okay, so i.e. 12x squared minus 24x plus 17 can't equal to 0. So there's no x's that will give the answer to be 0. In other words, there's no real roots here. Okay, so what you can do is look at the discriminant and prove that actually that's the case. There's no real roots. So if you remember the discriminant, the a is equal to that number there, the b is equal to that number there, and the c is equal to that number there. So the discriminant, b squared minus 4ac, so it'll be minus 24 all squared, minus 4 times 12 times c, which is 17. So if I work that out in my calculator, and I get minus 240. So in other words, when you work out the discriminant of this, it comes out to be negative, which implies no real roots. Okay, in other words, there's no situation where this is equal to 0. Okay, so if there's no situation where it's equal to 0, okay, i.e. 12x squared minus 24x plus 17 is not equal to 0, or f dash of x is not equal to 0, okay, all we got to see then is if it can't equal 0, well, is it positive or negative? Okay, is it positive or negative? And if it's positive, it will be increasing. Okay, if it's negative, it will be decreasing. So you just put in a value. So we'll just check with x equals 1, for instance. Or in fact, let's check with x equals 0, because that would be easier, wouldn't it? F dash of 0, I don't need to use my calculator then, equals 17, positive. So if it's positive for one value, it's going to be positive for every value, yeah? Because there's no way that can equal 0 ever, so it will never cross the x-axis.